So this SAT problem asks us to figure out which of the expressions shown is equivalent to this binomial. So I noticed that these answer options all have this 6x squared y squared out in front of a set of parentheses. And so I just kind of glanced at this and I realized that the greatest common factor shared between these two terms numerically is 6. This has an x squared, and this has at least x times x as well. And both of these have a y squared. So the greatest common factor is actually being factored out to produce the correct answer option. Now, when you factor out a common factor, you're essentially undistributing. So if you undistribute 6x squared y squared from this initial term, you're going to need to divide that initial term by what you're undistributing, by what you're factoring out. And when we do that, the numerical value associated with that first term, the coefficient, is going to become a 1, right? 6 divided by 6. I'm removing x times x. I'm removing 2 of the factors of x. That's going to mean I have 6 of the factors of x remaining inside the parentheses, and I'm removing both factors of y. So hopefully it's obvious where we get the x to the 6th from that initial term. And then when I factor 6x squared y squared from the second term, dividing 12 by 6 gives me 2. The x squared and the y squared have both been removed. We are looking at option C. As I was ending that, I realized we should probably say why option D might be tempting to choose. When you factor x squared from x to the 8th, you are not going to divide the exponents. You are not going to take 8 and divide by 2. That would give you what you see here in option D. Hopefully the undistributing discussion makes sense. If I distribute this x squared back into the x to the 6th, I clearly get back to x to the 8th. That does not happen if I distribute x squared into x to the 4th. That would only take me back to x to the 6th, which is not what we had up here initially.